get started with Vishal. Thank you so much, Vishal, for joining us today, for taking out your time for this webinar. I really, really appreciate it.
My
Uh,
pleasure.
why don't we get started with your brief introduction? So I'll hand it over to you now.
Hi, everyone. My name is Vishal Kashliwal, and I work as a senior deep learning software engineer at Intel. So, a little bit on my background. I actually come from the field of astrophysics. So, I did a PhD in astrophysics, and then I did a postdoc in astrophysics. A PhD holder and being a professor. And so after having finished my after having done my postdoc for a year and a half, I decided to venture into another area in life, which was high performance computing. And I started working on my skill sets to basically apply high performance computing to deep learning. And after learning a little bit, I went to work for a company called Wave Computing, which is here in the Bay Area in Campbell, California. And the goal of wave computing is to build a chip for deep learning. And so I worked there for a year and a half, and now I'm at Intel, working on other related things at Intel, which I'll get into in a bit. So that's my background.
Thank you so much, Vishal, for sharing your background. So let's get started with some questions specifically really on deep learning, right? So that our audience can get a brief overview or like a high level idea on it, and then we can deep dive into more details. So how would you define deep learning, and how is it different from AI and machine learning? Because there's a lot of confusion around these three terms together, especially those who are not super technical or those who are in very early in their career.
So I'm glad you asked that question because coming from a physics background, it's something that I've thought about a lot. And so, sort of, here's my take on it. So, my take on it is that the ultimate goal in all of this is artificial intelligence. Intelligence is, broadly speaking, a system that behaves and thinks in a manner that is similar to our own, or maybe even superior in some ways. This has been a long cherished goal of futurists, science fiction writers, and even scientists for hundreds of years. And various people have applied their own sort of spin on it and their own criteria. There have been various attempts at getting closer and closer to artificial intelligence. And there's also a lot of effort on defining what it means for some system to be artificially intelligent. So for example, one popular test is this thing called the Turing test, where you basically say, okay, it's a box. The system is hidden inside a box, and you can pose questions to it. And if the response is indistinguishable from a human being, then the system is artificially intelligent. That's one of the most basic tests that people have proposed for determining whether a system is artificially intelligent. Onto motivation. One of the big motivations for artificial intelligence is just it attempts to answer questions about who we are as individuals, as a species. Is it possible for another organism to exhibit the same sort of intelligence that we see in each other? Or is it the case that there's something unique about us that makes it possible for us to display this kind of behavior, but that cannot be replicated by other systems? So that's broadly speaking what the goals of artificial intelligence are. Now the question is, how do you get there? So deep learning and machine learning are basically methods for achieving artificial intelligence. So going back to machine learning for a minute, machine learning is a field and deep learning is a subfield within machine learning. So there are various techniques for teaching machines how to learn, how to answer various useful questions. And one of the techniques that one is able to apply is this technique called deep learning. And specifically what deep learning does is it uses an algorithm known as an artificial neural network to learning. So take, for example, the question of planets going around the sun. So there's this inverse square law of force called gravity. And with knowledge of the force and some mathematics, one can work out with tremendous precision how planets go around the sun. One can, predict all sorts of effects that one is able to observe in real life. And then with even more sophistication, when you start throwing in a theory like general relativity, you can even explain anomalous behavior, like there's this famous precession of Mercury. Now, the interesting thing here is that the system is simple and the system is completely deterministic. So what that means is that once the planet is going around the sun, it can be described perfectly down to observational error. And the idea is that as you reduce that observational error, you still manage to find that the system behaves the way the equations predict. So this is a deterministic system. And not all systems in life are deterministic. A further complicating matter is that this system is simple, right? Planets going around the sun can be described either using Newtonian physics or Einstein's equations. But fundamentally, it's not a very complicated situation to examine, even if the theories sound complicated when you study them. On the other hand, there are many, many, many systems that one can imagine, systems that one runs across in everyday life. For example, take the case of something as simple as a stock in some company. That stock holds value because of the fact that the company is earning revenue and that the company has some assets. But the price of the stock varies dramatically from minute to minute to hours to days and months and years. So why does it vary that much? Is the intrinsic value of that stock actually changing as quickly as we perceive it to be when we look at the stock market price? And the simple answer is no. The actuality of what's happening is that there are human forces that are trying to determine what the value is, and they disagree with each other because the system has two features. One is it is very complicated, and the other is that it has an inherent level of stochasticity built into it, random behavior that you cannot deterministically give the value of. And those two features make modeling a stock market quote very difficult using sort of methods that you might traditionally consider to come from science. So one of the goals of machine learning is to be able to provide useful predictions for systems that are so complex and so complicated and or behave so indeterministically that it is almost hopeless to imagine coming up with an equation to describe them. So that's basically what the goal of machine learning is. Now, within machine learning, there are many, many different methods. There are support vector machines, there are linear regressors, all sorts of different techniques for computing the output that the machine learning system is supposed to compute. And one of these methods is the use of artificial neural networks. Now, before the 2010s, people were limited in how big they could make the artificial neural network. So the artificial neural network is a system that you can scale up in size. And when you scale the system up in size, you find that it predicts values better in many cases. But one feature that is common to all machine learning systems is because there is no inbuilt knowledge of what the system's dynamics are, you have to train them by giving them examples, by giving them samples. So you can think of these machine learning systems as basically being like people, and you throw examples at them. If you see this, this is the right answer. If you see that, this is the right answer. And a good system learns how to predict the output even if the inputs are very different. And so in all of these methods in machine learning, you have two phases. You have a training phase where you show the system samples and solutions. And then you have an inference phase where you use this trained system to make predictions. So in the case of neural networks, up until the 2000s, people were sort of limited in how deep they could make them, how complicated they could make the actual neural network. And then with the use of GPUs, they found that they could begin making these systems very deep, meaning that there'd be many layers in the artificial neural network. And they found that this gave the neural network tremendous predictive power. And that's where that term deep learning comes from. It's because you use a deep neural network to learn the solution to some problem that is intractable using a shallower, smaller neural network. So that should help put machine learning, artificial intelligence, and deep learning in some sort of context for everyone. It's it's a pretty interesting and dynamic field that has developed very quickly over the last 9 to 10 years.
Awesome. Thank you so much, Vishal, for sharing this information on deep learning. Really, really helpful. And as you said, like this field is growing, especially in last 9 to 10 years. Uh, so there are a lot of software engineering professionals who really want to get into this particular domain, like deep learning. So, how would you suggest? Uh, like, what's an ideal path according to you to make this transition from a software engineering career to career in deep learning?
Systems are very big and very complex, and there are many, many, many pieces to the puzzle, right? So there's no such thing as a job description when it comes to what a deep learning software engineer does. So depending upon one's own specialty, there are various sort of aspects of the deep learning software, hardware, tool chain that one works on. So for example, in my case, I don't train deep neural networks to solve a business problem. My job is to write the software that runs on the hardware that is developed by the people in Intel's hardware division. And this software is designed to be a very low-level set of software codes and algorithms that is called many, 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 many times by the people who actually train neural networks for a business purpose. So as you can see, that already establishes that there are many different sort of entry points that one can make into this area. So my personal philosophy is one has to recognize one's own strengths and one's own existing corpus of knowledge, and then decide how is it that I can apply this to a problem that is using deep learning to solve some business need. So, for example, if you are a person who does, hardware verification, well, there are people in the world who are working on chips for deep learning, and I can talk a little bit about why this is the case. And they need to have their hardware verified before the hardware is, frozen, so that their product is competitive and has a place in the market. And that's where you could come in. That's where you could break into the field of deep learning. Now, on the other hand, there are some people who come from a more analytical background. Typically, people who come from physics, astrophysics, math, and these people have knowledge of how to go about taking data, processing it, organizing it, and then asking meaningful questions that you can apply, that you can learn answers to by using a deep learning algorithm. So that's the sort of more data sciencey and you could fall anywhere in the middle. There are many, many, many problems when it comes to engineering a full system for deep learning that you need a very different set of skills for, where you can find application for whatever skills it is that you've developed over the years. Right from how to process large amounts of data, how to store large amounts of data, where to store large amounts of data, how to make it easily available, to how to actually find an algorithm that works for a specific problem. And then you have the standard sort of software engineering that needs to be done, where you're creating an API for some user who does not want to understand the system to be able to use the system. So so my answer is, find your own strengths and decide where your strengths would be most useful and critical, and try to hone your strengths so that they can be applied there.
Mm-hmm. No, that totally makes sense. Thank you so much, Vishal. So, Vishal, suppose if you are an interviewer and if you are interviewing a candidate for uh, an entry level deep learning software engineering position, what are the top three skills that you'd like to see in the candidate or on a candidate's resume?
uh, Algorithms and math and statistics. These three things are, universally useful. You can never end up in a situation where knowing more math or knowing more statistics or algorithms is a bad thing. That's almost never the case. So these are three sort of core areas that I would always focus on. And then the other thing that's always important is workability with other people. We it's not as if we work in isolation from everyone else. We have to work with other people. We have to be acceptable to them. We have to be nice to them. We might be better or we might be worse, but we need to be in the position where the other person enjoys working with us. Because at the end of the day, one person can't create all of this stuff by herself or himself. And so it's very important that the person have the sort of personality and work culture that encourages other people to work with them rather than discourages other people from working with them. That's a second skill that I would look at. And the third skill that I would look for is curiosity and passion, right? I mean, for some people, their job is just a way of earning a paycheck, and they get their satisfaction in life from other things. And I'm not against that. Everyone's in their own position. But what I find is that if you're looking for someone who, will stay up till 3 in the morning trying to debug something, it's usually only because is a labor of love for them. And that's a very important skill. And especially when you're breaking into some area and you're young, that's something that you can easily do that, a person who's equally passionate, who's older, may not be able to do just because of life's pressures. So that's those three things I would look for in someone. Those three skills are something that I would value.
Mhm. No, I think those three are absolutely the most required skills. So there are a lot of resources available online, right? Today, like on YouTube, here and there are tons of resources, and most of them are good as well. So how one can distinguish which resource to follow to prepare for any interview and which resource to avoid? So are there any specific resources that you would recommend for preparation of deep learning software engineering interviews?
So in my opinion, good resources for learning about deep learning are there's a set of books that I can recommend. One of them is a book called Deep Learning by Ian Goodfellow and Joshua Bengio and a couple of other people. Another source are the papers themselves. So one of the things that I think many people don't know about that is actually a very positive thing for this world is that there's this website out there called Archive. It's a free website. You don't have to pay anything for it. But as a rule, a lot of scientific papers are submitted to the archive before they make their way to a journal. And so the archive ends up becoming a free source for accessing genuine scientific literature, the exact same literature that gets published, but without having to pay for the journal fees. Now, what the journal brings to this is the journal brings the editorial process. And what happens is that eventually, after the journal has accepted a paper for review, the paper ends up getting revised on the archive so that it's up to date. So you can always be sure that if you look at a paper on the archive, it is as correct as one can possibly be. And one just has to be careful to make sure that it is published or has been submitted for publication, because in principle anything can be submitted to the archive. This is part of the reason why academic journals exist, is because there's a peer review process there which does not happen in the archive. So my suggestion is, combine the habit of reading sources like Medium, the morning paper, with actually going on the archive and looking at the papers that are published there. Thankfully, the research being done in the field is generally, pretty easy to understand. It's not as complicated as some of the more modern math tends to become. And so it's possible for most people to follow these papers without getting lost in a lot of math. And typically these papers also have a GitLab component or a GitHub component. And it's very important to go look at that, because it turns out that the paper may not describe something in enough detail for you to be able to understand what's happening mathematically. But the sort of gold standard there is the actual software that is posted on GitHub. Well-known books in deep learning. The Goodfellow book is a good starting point, and move to sources like Medium and the morning paper, but back it up with an examination of the actual research papers themselves. They're freely available on archive, arxiv.org.
That's great. Yeah, because as per my knowledge, I think most of the journals or like the research paper, they're available only when you take the subscription of these big journal platforms. But good to know that there is a platform where they're available for free. Okay, so here's my next.
Uh, very.
Sorry, Vishal, I think I lost you for a second.
I said
Yeah,
that the archive is a treasure trove of information, and it's all original research, the same as you'd get out of the journal.
that is amazing. That's really good to know. Perfect. So Vishal, as you have been working in this domain for a very, very long time, what are the most pressing challenges that you face in your everyday job as a deep learning software engineer?
I think the biggest challenge that I face in my everyday job as a deep learning software engineer is getting unstable code to work. So, I work in very close to the hardware, and I work on the system before it's frozen. So this is when the hardware is being designed. You want to design the hardware correctly, and the only way to do that is to run the hardware, run real workloads on the hardware. But since the hardware isn't ready yet, you don't have the option of running on the hardware. It doesn't even exist. And so what you have to do is you have to use various simulators that are designed to mimic how the hardware will run. And usually there's a range of them, with increasing fidelity. And as a rule, because the hardware is not yet ready, and because the specifications have not yet been frozen, these simulators rarely ever run completely flawlessly. And so you always have to go in and sort of figure out, okay, what's going wrong. And then you have to, contact the people who work on the simulator and say, hey, I think, this is not quite how it should be. And then they say, yeah, yeah, we need to fix that. And then you work together with them to find, a fix and get it in the emulator so that it can be run past that point. So that happens a fair bit.
Okay, perfect. So Vishal, if I'm going for an interview for a deep learning position, so what should I thought through before going to an interview?
One of the things that um, people would value is if you show some curiosity about the field. See, again, it comes down to demonstrating passion. In my opinion, passion is the single most useful quality to have in someone if you want them to do something. People do all sorts of crazy things because out of passion. There are people who've tried to go to the North Pole and the South Pole. There are people who've tried to climb mountains just because they're passionate about it. Now, how do you show that passion is the question. See, your resume and your accomplishments, they show that you are, someone who's able to learn new things and to grasp new concepts, and someone who does a great job of programming. But at the end of the day, if you want to stand out, you can demonstrate your passion for the job that you're applying for. And the only real way to demonstrate that is by showing curiosity. See, a person who's not passionate is not curious, as a rule. It takes passion to drive curiosity. And so one thing that I think, you could do to prepare for an interview is, if someone asks you the question, what is your favorite deep learning paper? Or, what is the favorite set of papers in deep learning that you've run across that you're thinking about right now? Have a good answer for that question. I can't answer it for you. I can certainly point you in directions that I find personally interesting. But what that demonstrates to the person who's interviewing you is that this person cares so much about the area and the field that they're going out of their way to learn more about it, and that's a very powerful indicator. So that's my advice and my suggestion. The other
Hmm.
thing is, make sure that your basic statistics are in place. So machine learning departs from statistics very quickly, but the original foundations of machine learning, the original sort of area of human reasoning that machine learning comes out of is very much statistics. And so it's still important for a person to know how to think in statistics and what basic concepts and principles are in statistics, because that kind of foundation is very strong for being able to reason in machine learning.
Hmm. That's perfect. So Vishal, in my in my 5 to 6 years of career, I've realized that it's very important to select a right employer, at least at the beginning of your career, right? So what should a candidate consider when selecting an employer for deep learning industry?
That's a really good question, and I think one has to answer that question um, on many different levels, right? So I think one of the most important qualities to look for in a good employer is how well the company is run. And if you'd asked me this a few years ago, that would not have been my first answer. But I think what distinguishes a very good company from a mediocre company or a failure is how it's run. I think that the management of the company is paramount and critical. And I think that a company with really good ideas, if it's not managed well, will absolutely not be able to be competitive in the market and be able to perform. So that's one thing that I would look for. Now, the interesting question is, how do you know how well it's run? So past record of success is a good indicator. Either the company itself has already established itself in the field, and so you can look at its past track record. So, for example, when you're applying to a Google, you're banking on the fact that a Google has Google has produced successful software and hardware products in the past. Um, Sometimes you don't have that luxury because the company is a startup. In which case, what I would do is I would look at the leadership of the company, and I would see what their prior experience and their prior backgrounds are, and I would look for roundedness. I would try to figure out what it is that the company needs. Okay, we need to have someone who knows supply chains. We need to have someone who knows how to manage the software team. We need to know someone. We need to have someone who knows how to productize the technology, and we need to have someone who does marketing. So so identify what you think the company needs, and then make sure that the senior leadership in the company has those bases covered. Because if they don't have those bases covered, then it's quite likely that someone's trying to fill that position without having years of experience and knowledge filling that position, and that can be troublesome and problematic sometimes. So that's what I would look for in an employer.
Great, awesome. So yeah, once suppose if I get a job at my targeted company, I'm sure there must be a lot of competition even in this particular industry. So how can I become an effective deep learning software engineer so that I can progress really well in my career?
Well, that's a great question. And my only suggestion there is that you have to demonstrate in some way that you are um, a great person to work with. Now, whether that is because you get things done on time, or whether it is because you're very sharp and you have good ideas, there are many different aspects that can make you stand out from your peers, right? Are you able to you know identify um, problems in the organization that you think you can help fix, and are you able to provide good solutions for those problems? Are you able to take charge and help manage the implementation of those solutions? Are you good to work with? Are you an overbearing person? Let's say that you decide that, okay, there is this aspect of the product that the company has overlooked. This is typically at a small company, but let's say that that happens, and you say, okay, fine, I know something about how to contribute there. I know something about how to fix that problem, and you start trying to help. But it turns out that you're very overbearing, you're very dictatorial, you're not a pleasant person to have other people work with. Your attempts to fix that problem can fall down completely. And so it is important to know how to lead and how to manage effectively in order to be able to fill those holes. Now, if that's not your cup of tea, you can be a great technical contributor. Those are also extremely valuable, right? I mean, it is very difficult to find people who have solid technical knowledge, and just being that person helps. And if you are that person, then make sure that you share your technical knowledge with everyone. Make sure that you're not that person who tries to show how superior they are to everyone in their technical knowledge, but be that person that helps everyone rise up. Because the truth of the matter is, you're not really competing with the people in your company as much as you as a group are competing with the other companies in the marketplace. So rather than try to be the outstanding engineer in the company, try to make the entire company succeed. try to make everyone do good work, do great work, so you can all, ride the wave of success together.
Perfect. That's very well. So, Vishal, we have a question from one of our attendee, Alex. So, Alex says that I do not have a technical background. I'm a product manager. I cannot code, but I do understand technology. What do I need to do to get started in deep learning industry?
So that's a great question to ask. And my sort of good news answer there is, it doesn't matter if you're not a technology person, you're a product manager. And product managers are very important in this, because only product managers have the power to decide whether or not some technology that, you will always find people in companies who are enthusiastic about a certain piece of technology. And it's because we people who are in technology, we get very excited by it. We get very, taken up by it. But that doesn't necessarily mean that that technology is suitable for the market as it is right now. And as a product manager, your unique expertise and skills are deciding what it is that the product needs to be. And my suggestion is, learn what deep learning allows you to do, right? Try to get a broad overview of what it is that deep learning can help with, what it cannot help with. So what that means is that you do need to learn a little bit about the technology behind deep learning. But my suggestion would be, partner up with someone who is a technologist, and help them figure out, work together with them. They can focus on the technology side, and your goal should be to learn, okay, what is this technology good for? Where can I apply this technology? What are its limitations? What are some of the things to worry about when trying to, implement a solution with this technology? That's where, your role as a product manager can become extremely valuable. So that's my um, answer there.
Hmm. That's perfect. Thank you so much, Vishal. And okay, so my next question is, what's the best job search strategy for deep learning software engineer position? There are a lot of job portals available, uh, and I think the networking in the referral works the best. But what would you recommend? What are the areas or what are the groups that you would recommend to join where candidates can find the most recent open positions in this industry?
Various, groups and various websites. So LinkedIn, for example, a lot of positions get posted there. Companies obviously always have their own, job boards where they list open positions. But really, I think the most powerful force there is networking. I think the most powerful force there is to, you know, form a relationship with someone, and don't try to make it a relationship that is purely about getting a job. It has to be a deeper relationship than that. And when you've established that sort of relationship, you will automatically find jobs that are a good fit. Now, this is not so much for people who are breaking into the field, breaking into, coming straight out of university. But once you've had a job or two, you really have to take all the recruiters that you can find, and treat them with, all the respect and dignity that they deserve. I mean, they do very hard jobs, and you cannot dismiss them. Never ignore them, never simply write back, I'm not looking. Be nice to them, because even if they're not recruiting for a job that you are interested in today, if you tell them what it is that you're interested in, they may come across that sort of position, a week from now, a month from now. And when they do, they'll think of you, because they'll remember that you were this nice person that spoke well with them, explained what they were trying to do. And the first person that they'll then turn to is yourself. Are you interested? Is this something that you're interested in? So that's my suggestion. Events that you can meet other people in the field at are also very important. So for example, there are various conferences and seminars that you can go to, where you can meet people. But the key is to not approach it with the mindset of, I want a job. The key is to approach it with the mindset of, I want to learn about something interesting, or I want to do something interesting. And I'm looking for people who want to do the same thing, so we can all work together to get it done.
Hmm. Great. So, Vishal, we have a question from Dens. So, Dens asks, can you suggest healthcare application of deep learning? Only a
So
few have them.
Sorry, excuse me. I'm sorry. It was a
No
bit.
problem. No problem. Let me repeat the question. So Dense says, can you suggest healthcare application of deep learning that only a few have done?
That only a few have done. Okay, so one of the most interesting problems that I ran across when I was a graduate student actually was, so a lot of my graduate work was in an area called time series analysis as applied to astronomy. And while I was sort of just browsing the internet one day casually, I came across an interesting article that said that a deep learning algorithm has managed to beat expert human, human experts on detecting cardiac arrhythmia in I believe, and I misremember because this was a long time ago, but I believe there are 12 different kinds of cardiac arrhythmia, and I think the algorithm beat the human experts on 9 or 10 of these types of cardiac arrhythmia. And the interesting thing there is that cardiac arrhythmia is a very difficult diagnosis problem. You can't simply cook up a simple statistic that tells you whether there is cardiac arrhythmia or not. The heartbeat shapes are not completely uniform, the sizes are not uniform. There are lots of variations depending upon stress and exercise and a host of other factors, illness. So it's very difficult to cook up a simple formula, statistical formula that answers whether or not the person has some kind of cardiac arrhythmia. And this deep learning algorithm was able to do that. It was able to diagnose cardiac arrhythmia very accurately. So that's one example. Now, has it been productized? I am not 100% sure. In sort of the medical field, there's more to it than just finding something that works. One has to make sure that it's not a hazard, it's not a health hazard. So it might be stuck in that. Unfortunately, I haven't followed up on it enough to know if it's productized yet or not. Another area is detecting cancerous tumors. So if you imagine, when you perform a scan of the human body using MRI or CAT scans or PET scans, it generates a tremendous amount of data. It generates a lot of data, and it's very difficult to analyze that data. It's all done using human experts, technicians who are trained to recognize cancerous tumors and growths. But deep learning is one technology, is an example of a technology that can be used to help automate that. And the benefit there is that the end result may be more reliable. So it may be that you reduce either the rate of false positives or you increase the rate of true positives. But either way, that's another very big application for deep learning in medical imaging. And there are many others. I mean, a lot of techniques that have been done by human beings traditionally can be done using deep learning. And actually, one of the great things about deep learning is that from a business standpoint, deep learning is not as exploited as it could be. There are many applications that are amenable to deep learning algorithms that where deep learning is not yet being applied. And so there's a lot of scope in that area.
Perfect. Thank you so much, Vishal. So as we are reaching at top of the hour, I'll just take one last question. So what's one advice that you have for deep learning software engineering aspirants to become successful in their career?
Learn, learn, learn. It's a very rapidly changing field. What used to be true last year is no longer true this year. What used to be true 2 years ago, people have already forgotten. You have to keep up with the knowledge as it changes. You have to keep up. You have to be willing to keep up with the knowledge as it changes. It's actually staggering just how quickly the field is evolving. And keep your mind open to other possibilities. So as an example of this, it turns out that artificial neural networks don't work the way our brain does. Even though people say, oh, it's like the human mind and things like that. The truth is that there's a fundamental difference between how the neurons in our brain work and how the neurons in an artificial neural network work. And there's this whole area of research called spiking neural networks that try to create computer algorithms that more closely mimic how the brain works. The problem there is that the field is very immature. It has yet to hit the point where a lot of the technology can be commercialized, and so it's still in very nascent stages. Now, if you think to yourself, okay, I'll become a deep learning software engineer and I'll learn about convolutional neural nets or recurrent neural nets or whatever, and then 2 years later, when these spiking neural networks become viable commercially, your body of knowledge will be completely outdated in a few hours, as soon as the paper comes out that announces that they can do something useful with spiking neural networks. So you have to be willing to keep up, and you have to be willing to keep enriching yourself, your knowledge, and your skills.
That is perfect, Vishal. When you said like learn, it reminded me of situation like whenever candidates ask me how can I do well in interviews, I say practice, and practice. So it's one and the same thing. Well, thank you so much, Vishal, for your time and for sharing your experience, knowledge, and
I,
insights on deep learning. It
I'd
was
like to say thank you to all my listeners. I'm glad to have had the chance to speak with you, and I wish you all the very best of luck going forward.